Well, welcome back. Section 1 review problems. We're being asked to find in the question 1 the gram formula mass of each compound. As soon as I know that it's a formula mass, I now know it's all about ionic compounds I build by charges. Ionic compounds have charges in them. So, lithium, who carries its +1, sulfide, who carries its -2, Li2S. How many grams of lithium sulfide do we need to weigh out to get 1 whole mole of lithium sulfide? Lithium, 6.94, but there's 2 of them, so I'll double that, plus, and the last name was sulfide, 32.07 grams. 2 decimal places, 45.95 grams of Li2S, lithium sulfide. How'd you do for letter B? Iron 3 chloride. Iron with its +3, chloride with its -1. Balancing the charge, FeCl3. How many grams of FeCl3 do I need to weigh out to get 1 whole mole's worth of particles? Well, let's add 1 iron, 55.85, plus the mass of 3 chlorines, each of them contributing 35.45. Here's my iron, and here's the chlorine times 3, FeCl3, and we get a grand total of 162.2. And to carry 2 decimals, 162.20 grams of FeCl3. Sorry, that wasn't so neat. 162.20 grams of iron 3 chloride. And how about this one? Calcium hydroxide, Ca calcium, who's a +2. Did you find hydroxide, that polyatomic ion right here, OH, carries a -1 charge. So in a parenthesis, so important to take a group of hydroxides. Calcium with the +2 needs 2 units of that -1 called hydroxide to balance it. We need to add 1 calcium, 2 oxygens, and 2 hydrogens. Do you see how that distributes? The 2 carries throughout the whole parenthesis. There's 1 calcium, 2 O's, and 2 H's. Now a calcium contributes the weight, carrying 2 decimal places, 40.08, plus, we said there were 2 oxygens, and oxygens we agreed to round to 16.00, plus, and there are 2 hydrogens as we distribute through that parenthesis, 1.01, the atomic weight there of hydrogen, doubled. And we get a formula mass of 74.10, getting in the habit of 2 decimals. Let's see how number 2 went. How many oxygen atoms are there in a representative particle of each substance? Now this question was probably easier than it actually sounded. All we're doing is counting oxygen atoms. Not really any math at all, it's just a simple counting exercise. The hardest part might have been to write formulas. Ammonium nitrate. Ammonium is our polyatomic ion, NH4+, and nitrate is NO3 carrying a -1. Ammonium nitrate, NH4, NO3. Look inside that formula, and how many oxygens do you count? That's all it's asking me. You see that right there? There's just 3. That's all. There's 3 oxygen atoms. Letter B is just a fun word to say. Acetylsalicylic acid. It's the chemical name for aspirin. Acetylsalicylic acid. How many oxygen atoms does it contain? You got it right there. There's 4 oxygen atoms. Here's a molecule called ozone in letter C. How many oxygen atoms in a single molecule of ozone? See how easy these problems were? Just counting. And nitroglycerin. How many oxygen atoms do you count? Well, in the nitrate, NO3, but it's taken 3 times. 3 times 3 tells me there's 9 oxygen atoms. So in question 2, we were just really looking inside of a formula and counting specific oxygen atoms. That was it. Now number 3 looks like we had a little mole map work to do. Question 3, how many molecules, given this many molecules, convert to moles? So each and every time we're given the number of particles and want to head into the mole, particle to mole, using Avogadro as our exchange unit. If we have 1.50 times 10 to the 23rd molecules of ammonia. Now keep in mind, molecules of ammonia is a vocabulary match. Groups of nonmetals bonded together are indeed molecules. It's a simple one-step conversion. I have a number unit label, 1.50 times 10 to the 23rd. I want to go into the mole, so I divide by Avogadro. Number unit label, hitting out 1.50 times 10 to the 23rd. Divide by our Avogadro's number. And we have 0.25 moles of ammonia. Molecules canceled and we went into the mole. Letter B, we have 1 billion molecules of oxygen. 1 billion is written as 1 times 10 to the 9th molecules of oxygen. Is that a vocabulary match? It certainly is. Oxygen belongs to our Lucky 7 Club. The horses need oats for clear brown eyes. 1 billion molecules. How many moles? Well, if I had a 1 mole, I'd have an Avogadro's number. Now, how do we hit 1 billion on our calculator? We just hit 1, E9. That's 1 with 9 zeros after it, representing the number 1 billion. We divide out by Avogadro, and we end up with a pretty small number of moles. But 1 billion is a very small number compared to Avogadro's number. Carry 2 decimals, 1.66 times 10 to the negative 15th power moles of oxygen. Letter C. 6.02 times 10 to the 22nd molecule of bromine. That indeed is also a vocabulary match. He belongs to our Lucky 7 Club. Whoops, just as oxygen did. Dividing out by Avogadro. Takes time to write number unit label, doesn't it? But it's a good habit that we have to get into. Number unit label every step, every time. We'll divide out by Avogadro. 6.02 E22 divide by Avogadro. We get 0.1, as your scientific notation would have guessed. 0.1, 2 decimal places, mole of bromine. And one more for perfect page 3, today's lesson. Letter D. We have 4.81 times 10 to the 24th atoms of lithium. Again, a vocabulary match. No worries there. Vocabulary's matching. How many moles? Setting up our conversion, 1 mole of lithium. Divide out the atoms of lithium. Our calculator sequence simply looks like 4.81, E24, divide by Avogadro. And did you get a matching number? 2 decimals, 7.99 moles of lithium. If we all agree to carry 2 decimals, we all agree to write number unit label, and we're going to have a perfect A+ paper. You've successfully completed page 3. You're now ready to ask your teacher for the section 7.1 review sheet. This is the worksheet for our assignment due tomorrow. Good work, gang.